Hey guys, I'm Gia, and welcome to Geometry with G. Today's lesson is on similarity of triangles, area of polygons, and surface area and volume. Let's jump right in. First, we're going to start off with similarity, but before we jump into that, there's a few things that you guys need to know, just some essentials that we'll need to conduct our problem. First of all, a ratio is a comparison of two quantities by division. An extended ratio is a comparison of three or more quantities by division. A proportion is a statement that two ratios are equal. And yes, you guys guessed it, an extended proportion is a statement that three or more ratios are equal. Sorry guys, we can't jump in just yet. There's still a few more things that we need to know. First of all is the side splitter theorem. And this states that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally, and proportional just means equal. The corollary of that theorem states that if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. You guys are probably thinking, what the heck is a transversal? Well, a transversal is a line that intersects two or more lines at distinct points. Here's just a little example of the side splitter theorem for you guys out there that need a visual. So this is just saying that if RS is parallel to XY, then XR over RQ is equal to YS over SQ. Okay guys, finally we are at the actual problem. So let's take a look at the diagram, the figure that we have here before we do anything else. So here we see we have a triangle MNP. And we're trying to find the value of x in the diagram. So how can we use these parallel lines that we see here to solve our problem? Well, the segment KL is parallel to one side of the triangle MNP, and by using the side splitter theorem that we just talked about, we can set up our proportion. So let's take what we learned from the theorem and set it up. So here's our proportion. It's PK over Km is equal to NL over LM. And this is by the side splitter theorem. I'll just say SST. And now let's plug in our numbers. So PK was x plus 1. Km is 12 equal to NL is just x. And LM is 9. And now we can cross multiply here and here. And now let's simplify it. So it would be 9x plus 9 is equal to 12x. Now, how do we get rid of the x's here? So let's subtract 9x from both sides to get the x's on one side. Then we'll get 9 equals 3x. Simplify. X is equal to 3. And there you have it. Congrats guys, you just solved the problem. And now let's move on to chapter 10 where we're going to talk about the areas of polygons. And now we're on to area. Instead of telling you guys all the essentials that you need to know, I feel like it's best that I just explain it as we go through the problem. So let's jump right into it. Hello again, lovely people. Let's jump into this word problem. So it says Jason works for a company that makes signs. He wants to find the area of this 9-sided stop sign so that his sign company can make more of them. Find the area of this figure. Okay, first of all, I know you guys, or some of you guys, have a lot of trouble with word problems, and so do I. So I'm going to show you a method that I've learned over the years to help you get through this kind of stuff. And I call it the triple U. Looks a little something like this. You guys are probably like, what the heck is she doing? Well, each of these W's stand for something. That's why I call it the triple U, because there's 3 W's. Get it? Yeah. Okay, the first W stands for what you need to know. The second W stands for what you need. And the third W stands for what's the plan. Boop. There you go. Well, how can we answer all of these questions if we only have so little information? So let us use these questions in the next picture I have laid out for you in this next slide. Boop! Again! Now we can answer all of those questions. Okay, what do we know? We know this is a 9-sided figure, and as you can see here, each side is 10 centimeters long. Right here we can see the symbol for 90 degrees, so we know this is a right triangle right here. And no, people, don't freak out. This is not different. These are the same. This is just a little breakdown. This is a breakdown of this triangle right here. They just split it in half. So finally, we know that this angle right here is 20 degrees. Now what do we need? Well, we need to find the area of this polygon, but as you can see over here, we have a variable, so that means a number is missing and we gotta fill it in. And if you didn't know, this A stands for the apothem. And now you're probably saying, what the heck is the apothem? Well, the apothem is the altitude of the isosceles triangle. And an isosceles triangle is just a triangle with two equal sides. The apothem bisects the central angle and the side of the polygon. Now, how do we find this apothem? Well, we're going to have to use trigonometry. I'm going to teach you guys something called SOHCAHTOA. SOHCAHTOA. All these crazy letters that you see here, these all stand for something. So the S stands for sine, the C stands for cos, and the T stands for tan. And you can find all these on your calculator. All of these letters are actually grouped together in tiny little groups. So is together, ca is together, toa is together. Sine is equal to opposite over the hypotenuse, and I'll tell you what these are later. Cos stands for adjacent over hypotenuse, and tan stands for opposite over adjacent. Please excuse the ugly right triangle, but it's going to help you. Let's just say this is 4, this is 5, and this is 7. The two legs of the triangle, these are the legs, these are the opposite and the adjacent. And the longest side of the triangle, this is the hypotenuse. You guys get it? Okay, so now that we know all of this stuff, let's apply it to this problem that we have here. Boop! Okay, let's look at this triangle. So, as you can see here, here's the right angle. These are the two legs. And this is the degree that we have. This is the angle that is given to us. So, if this is the angle that's given to us, this has to be the opposite and this has to be the adjacent. So, if it's opposite and adjacent, that's O and A. So that would be TOA. So we're going to say tan 20 is equal to 5 over the apothem. Gotta make that a little smaller. Okay, now let's simplify. A is equal to 5 over tan 20. Now the area formula for this is A, that's a capital, is equal to half of the apothem times the perimeter. But trust me, it's really easy to find the perimeter. If we know that one of the sides is 10 centimeters, then we just multiply it by 9 since there's 9 sides. So the perimeter equals 90. So this would be equal to 1/2 times 5 over tan 20, which is your apothem, times 90, which is your perimeter. And now all we got to do is simplify. Put that into your calculator. Did you get this? If you did, great job. And remember, your area is always units squared. Now we're moving on to surface area and volume. Now there's not a lot you need to know for this next problem. You just need to know the lateral area and the surface area of a cylinder. So as you can see here, the lateral area of a cylinder is pi times d, which is the diameter, times the height, which is h. The surface area of a cylinder is 2 times pi times r times h. R is the radius and h is the height, plus 2 times pi times the radius squared. Okay, so here's our problem. As you can see, we have two paint cans here. These are both cylinders. And the problem says, the lateral areas of two similar paint cans are 1,019 centimeters squared and 425 centimeters squared. The volume of the smaller can is 1,157 centimeters cubed. What is the volume of the larger can? So we're trying to find the volume of the larger can. Let's use our triple U method. So what do we know? We know the lateral areas and the volume of the smaller can. What do we need? Well, we need the scale factor, and our plan is to use those lateral areas to find a scale factor a to b, then write and solve a proportion using the ratio a cubed to b cubed to find the volume of the larger can. Let's set up our ratio. So our ratio is going to be from the larger can to the smaller can. Let's start out with the areas. So it's going to be a squared over b squared, which is equal to the volume of the larger can, the area of the larger can, 1019 over 425. And to simplify the squared, we're going to square root each of these, which is going to get us to a over b is equal to 1019 over 425. Now let's go on to the volumes. So the volume of the larger can is equal to the square root of 1019 cubed over the volume of the smaller can, which is the square root of 425 cubed. But since we already know the volume of the smaller can, we can do this. The volume of the larger can, and the volume of the smaller can was 1157. So we put that over 1157 and equal that to this. And to simplify this, we're just going to multiply the 1157 on both sides. And here's your answer. Remember to always make volume in units cubed. I really hope you guys enjoyed this video, and I'll see you next time.